All right, last one. You guys are almost there. So now we're going to write our function rule, this time given a graph. So this one of the easiest things to do is to find some points on your graph. So that's step one, and then make the table. And we've already learned how to write the rule based on the table, so that's what's going to help us there. So first we got to find some points. So you want to look for points that are easy, like whole numbers. So look for some good intersections. So I've got one that looks like maybe up here at this intersection point. Okay, and then maybe here's another one. So right here. Down here's another one, looks like. Maybe let's get one more. So this guy here would be another good one. Okay, so then what we want to do is make a table given those points. So let's start with, I like to go from least to greatest. So I'm going to start with my -1 here, this guy. Okay, so my x is -1. What's your y value or your function value there? Well, I'm down at -4, so that's what's going to go in there, -4. Maybe I should zoom in a little bit. Get rid of my janky 4. All right, what about next one we had was right here. What's my x value here? Should be 0. I'm going to put that in, and then it's down at -1. Okay, next one is at 1, 2. And then that last one there is at 2, 5. Okay, so we didn't quite fill the table. That's all right. Let's take a look then at our table now. So again, we want to try to look for that connection between the input and the output. Well, let's see. I could do -1 minus 3. That would give me -4. Does that work with the rest? 0 minus 3. Crap. Nope. Not going to work. Not going to give me -1. So just subtracting 3 is not going to work, unfortunately. Maybe we should check, well, is this linear or nonlinear? This time we don't necessarily have to check the table. We can just look at our graph. Is it linear? Yep. So it should have just an x in it. We just have to figure out what's going on with that x. So let's see. Let's write down some of the stuff that we know here. We know it's linear. Let's take a look then at our, remember how we did that change in y over the change in x thing? So how much is our y value changing each time? So we're going from -4 to -1. Well, that's going to go up by 3. And it should, remember, it's linear. It should go up the same amount each time. So -1 to 2, yep, going to go up by 3. 2 to 5, yep, going to go up by 3. So you could actually figure out the next one. We should go up by 3 again, which would give us 8. And then if these are all increasing by 1, this would give us 3. So yeah, these are all going up by 1. Going up by 1. Up by 1. And up by 1. Good. So then our change in y is 3. So that would go on my top. My change in x is 1. So 3 over 1, that's just going to be 3. Remember, that's the number that goes in front of the x. So our function, let's just say f of x, we know is going to have a 3x in it. So let's see if just 3x works. Are we just going to multiply by 3? Well, -1 times 3, nope, not going to give us -4. So what else would we have to do to get that -4? Well, 1 times 3 is 3. We have a negative 1, so that would give us negative 3. And then we would have to take away another 1 to get down to negative 4. So it might be 3x minus 1. So let's just write that up there for a second and see if that works for the rest. If I multiply 0 by 3, well, that's going to give me 0 still. And then take away 1. Yep, that gives me negative 1, so that's good so far. Let's look at the next one. If I plug in 1, 3 times 1 gives me 3. Take away 1, going to give me 2, so that's good. 2 times 3 is 6, minus 1 gives me 5, good. 3 times 3 is 9, take away 1 gives me 8, so that's going to be our function. So then we can go ahead and put that down here. We have 3x minus 1. Next page. That should be your last page. We just have a couple other ones to do. So remember, our first step was to find some points on our graph. So let's do that. So it looks like we've got one here. Where is our next one? There's a good one. There's a good one. Another one. And then all the way up here is going to be another one. So let's go ahead and make a table. So I've got x and f of x. And keep going down. So that first one we've got, let's put this down for a second. Okay, we've got this guy here. So that's at negative 1 and then up to 4. So negative 1, 4. Our next one here, our x value is 0, and we're up at positive 1. And then we've got 1, 0 for our y that time. Then 2, 1, and 3, 4. Now think back for a second. In our other table, we saw this 4, 1, 0, 1, 4 pattern before. What function did it go with? Flip back a couple of pages and take a look. It should have gone with the x squared function, which actually is going to be kind of a tip-off too, because look at our function. It's not linear, so it's going to have some kind of an exponent in it. So think about x squared. Is this going to match x squared? Well, if I square negative 1, no, that's not going to give me 4. So what could we do? What would we square in order to get a positive 4? Well, we could square negative 2, or we could square positive 2. So let's see. Negative 2 is closer to negative 1. So let's say if we had to do that. In order to get to a negative 2 from negative 1, we'd have to subtract 1 from it. Will that pattern work for the rest? If we subtract 1 from our x value and then we square it, is that going to work? So let's take a look at 0. If I take 1 away from that, I would be at negative 1. If I square negative 1, yep, that's going to give me 1, so that would be good. What about positive 1 for our x value? If I take away 1 from that, that would give me 0. 0 squared, yeah, that's going to give me 0. Okay, so keep going. It should work for the rest. So what that's going to be, we took away 1 from our x value, so I had to do x minus 1. And then I took that, whatever that was, and I squared it. So that will be your function. And then our last one here is this funky V-shaped looking thing. So that's kind of like our curve function that we had above, but not quite. So one thing, I don't think we've covered it too much yet, but if you see a V shape like this, that's going to actually end up giving you the absolute value, which I think we actually graphed that one a few pages back. Yep, page 11, if you want to go back and take a peek there, we graphed the absolute value function, and that was that V shape. So you might want to go ahead and put a little note in there for that. So a V shape will tell you absolute value. Okay, so this time though, remember before when we had just the regular absolute value, you had that kind of like point of your V at 0, 0, and then it went up from there. So this is not going to be exactly your absolute value, but it's going to be pretty similar. So first, remember you want to find some points. So it looks like we've got one here. We've got one here. One right here. Here. And there's another one. So if we make our table, and we know we have x, f of x, well, that first one there, that one is at there we go. We're at -2 and then +3. So that is what we're going to throw into our table. -2, +3. Then we've got, there we go, -1, +2, 0, 1, 1, 2, and last but not least we had 2, 3. All right, so remember, absolute value is talking about the distance away from 0. It basically makes it positive. Well, remember, just our absolute value function then, if we did that with -2, the absolute value of -2 is going to give us +2, which isn't quite yet to 3. If we take absolute value of -1, that's going to give us 1, which isn't quite yet to 2. So what should we do to that absolute value that maybe would change our numbers to get us the right output? Well, we said -2, absolute value of that would be +2, so then I could add 1 to it. Would that work for the other ones? If I take the absolute value of -1, that's going to give me 1, and then I add 1 to that, yeah, that's going to give me 2. What about 0? If I take the absolute value of 0, that's going to give me 0, and then add 1 to that, yeah, that's going to give me +1. So that's going to be our ticket. You should go through and check the rest of these, but just for time's sake, I will help you out and let you know, yeah, that's your pattern. So our f of x function is going to be whatever the absolute value of your input is, and then we want to add 1 to that. So be careful. You want the +1 to be outside of the absolute value because you want to take the absolute value first. If I did like the absolute value of x plus 1 inside the absolute value, that wouldn't work. And you can check that in here. Like if I take -2 plus 1, that's going to give me -1. And then absolute value of that would just be 1. So that's not going to work. You want to make sure that +1 is outside of the absolute value. Okay, that should be it. So happy function writing. And if you have questions, again, let your teacher know. Otherwise, good luck working on your assignment.